This question says for the above rational function, they give us a nice little graph here. There's the function. Identify the interval in which it's concave down. Well, you can tell that right around here, I'm just kind of eyeballing it. There's a change. See how this is concave up, like a bowl turned up, and this also is concave up, like a bowl turned up. But then right in the middle, this section is concave down. It's a bowl turned down, meaning the f double prime is negative, and for this other two parts, f double prime is positive. Remember, because f double prime, second derivative, tells us concavity. So in this section and this section is bowl turned up, f double prime is positive. This section about, concave down, f double prime negative. So that means right there, whoop, wrong color. Right there and there, f double prime must be zero, and we call that an inflection point, or inflection points, I guess it is. They're both meaning, the second derivative of the f double prime goes from positive to negative, so in between it has to be zero. So it's zero, going from positive to zero to zero back to positive. And right where f double prime is zero, that's an inflection point, meaning it's where a bowl turned up and a bowl turned down piece connect, and a bowl down and a bowl up connect. Point of inflection. So we're looking for those two different points of inflection. This is what we want to find, those inflection points, because that'll tell us the concave down section. So how do we find those? We got to find out where the f double prime is zero. So we got some hard work to do here. Here's my suggestion. Let's take this function and let's rewrite it as 18. You know what I'm going to do? 2x squared plus 3.5 to the negative 1, because I don't like fractions if I can avoid them, right? So write it that way. Negative 1 power is the same thing. It just means move it down. And that way, when I start taking derivatives, which I'm going to do now, first derivative, we got to get all the way to the second. I won't have to do the quotient rule. So the negative 1 comes on down. Negative 18, that wasn't very clean. Negative 18, 2x squared, it's 3.5 to the minus 2, subtract 1, right? Times, right, chain rule, derivative of the inside. Chain rule says derivative of the inside, so that'd be 4x. Okay, let's clean that up a bit before we do another one. Let's multiply this and this, just bring this right here and multiply it. Use your calculator, and you'll get minus, what's that, 72x times 2x squared is 3.5 to the minus 2. All right, that's a little cleanup. Now we need the second derivative. So clean it up before we take second derivative. So now how are we going to do the second derivative? We do another derivative. Well, first time I did it, I forgot. These two, we got to do product rule. Now you might, because I was just in the rhythm, I was like, we didn't do product rule here. Why do we suddenly have to do product rule? Or didn't do it here, I mean. Because this now has an X. See, this 18 back here, he was just 18. He didn't have an X. So he's just sitting there. We don't need to use the product rule. But if we have two different pieces that both have an X, we have to do the product rule. So we have to do the product, which means what? It means they take turns. So this guy goes first. He'd just be minus 72, right? Derivative of minus 72x. That one power comes down, subtract one, he's gone. Times the second one, unchanged. Plus the first one unchanged, which would be minus 72x, times the derivative of the second. So this is his turn. Here comes his derivative. This was this guy's derivative. Derivative of the second one. How do we do that? That minus 2 is going to come down. Minus 2. And the inside remains the same at first. Subtract 1 from the power. Minus 3 times the derivative of the inside, 4x, right? That was the chain rule right there. Times the derivative of the inside. Okay, did you follow all that? So we did the derivative of the first, minus 72x is minus 72, times the second unchanged, plus the first unchanged, times the derivative of the second, which is the hardest, bring down the minus 2, keep the inside the same at first, lower the power by 1, times the derivative of the inside, chain rule. Okay, let's clean that up. Well, yeah, let's clean it up a little bit. All right, here we go. So I'm just going to go minus 72 times that 2x squared plus 3.5 minus 2 plus, no, I'm going to say plus because I'm going to have a negative 72x, a negative 2, and a 4x. I'm going to put them all together. So if you multiply those, in fact, actually, and I'm just going to write it 72. I have a reason. I'll show you why. Times 8x squared. See what it might not make sense what I'm doing. Times 2x squared plus 3.5 negative 3. I'm going to show you in a minute. But so what it is, I took that 4x and I multiplied the x and the negative 2 to be, it's two, by the way, two negatives. Yeah, let's do this. Two negatives made positive, right? Okay, and then I just left the 72. Why? Because there's another 72. I'm going to do something tricky. So I'm just going to leave that 72. I'm going to take the 2x and the 4x. They made 8x squared, right? Okay, now what am I going to do? Well, first off, I got to set this equal to 0. Because what? Because I'm trying to find where the second derivative is 0. Those are my inflection points. These will be these 2 points, and that'll tell me the section that's concave down. There's the answers already. How do we get that? We got to set these equal to each other. So to do that, I'm going to grab this whole chunk here, jump it to the other side. So then we'll have, okay, right here. So 72 times 8x squared. Or actually, you know what? Let me just get rid of these 72s right now. They're bothering me. Divide by 72. Divide by 72. Divide by 72. Divide by 72. So that's why I wanted to do that. Right? By the way, see how I'm looking at this? This guy's the separator. Pluses and minuses outside of parentheses are the separators. This is all one big term. This is all another term. Jump this guy to the other side, get rid of the 72s. So we got 8x squared. We've got 2x squared plus 3.5 to the minus 3 equals, jump that guy to the other side. And it becomes positive 2x squared plus 3.5 to the negative 2. You with me? This negative jumped over here, became positive. 0 over 72 is just 0. That's gone. Positive, and we got rid of 72, so it's just that. Okay? Now, we're close. We are so close. So now, we got to get rid of these guys. We'd like to divide them maybe, but see they're different powers. What you can do to get rid is you just multiply both sides by what will here. So I'm going to multiply this side to the plus 3. You'll see why this works. And multiply this side by the same thing. You have no choice. You got to do the same thing to both sides. Watch what happens. First off, what happens when the same two things multiply? Maybe I can just, if I have room to explain it. What if you have, whatever, is some kind of expression to the third power and some other expression to the nth. Remember, powers add. It's expression to the 0 because it's 3 plus negative 3, which is 0, which is 0. Powers add. You know that, right? Like x squared times x to the third is x to the fifth, right? So the same thing is true if you have big old expressions. Those powers add. So it's 0. And what's anything to the 0 power? 1. So this and this just become 1. It's 1 times 8x squared. Isn't that nice? Okay, what happens on the other side? Same thing. Powers add. So it's going to be to the positive 1 power. See how that worked beautifully? So if you got two big olds, that's something to learn here in calculus, how you handle, you got two big old expressions, the same expression twice to different powers, multiply by the lowest one. Negative 3 is lower than negative 2. Multiply both sides by the lowest one, and that makes this one just become 0 power, which is 1. The other side is going to become 1 power. So I'm going to have 2x squared plus 3.5 to the 1, positive 1 power, right? Because these powers add. Negative 2 plus 3 is plus 1. So what's that then? Well, then that's 8x squared equals 2x squared plus 3.5. That 1 power is not doing anything, right? Now we're getting places. You seen how you handle these ugly things? This is a big part of learning Whoops, that's not the right thing. I'm talking. I'm doing the wrong thing. Let's subtract 2x squared on both sides. Okay, boom. 6x squared is 3.5. All right. Divided by 6. Boom. We get over here. We're basically done. X squared is 3.5 over 6. What do? We root it. And remember, when we put a roof on the house, up and down the ladder. Don't forget, we put a root on both sides, plus or minus. We knew there was two answers anyway, so x is plus or minus square root of 3.5 over 6. Hit the buttons on your calculator, and you will get these magic numbers. 0.7637, I think it is 0.7637 plus or minus. We found, and that's our answers. How do we know that's where it's concave down? Because those are the two places where the second derivative is zero. Those are inflection points. That's the part that's concave down. So we took the first derivative, took the second derivative, set it equal to zero, solved it. That was a little complex, and we got our answers. There we go.